Good afternoon, all. Am I audible? Just reply me. Yes. Okay. Thank you. Okay. So we'll move. I'll start sharing the screen. Just a minute. Yes. The screen is visible. Yes. Okay. Thank you. Yeah. So in the previous part, we have started with the unit number 3. Okay. That is modern serving equipments and road project. Okay, so in which we have started with the principle of EDM. Then what do you mean by EDM? What are the types of EDMs? That is electromagnetic distance measurement. What is the use application? What are the applications? Correspondingly, which EDM is to be used where and how it is to be used. Then correspondingly, what is the basic principle of that and what are the applications that we have seen in the previous part, okay, of this unit number 3. So moving further, okay. Okay, so in this unit, we are the second part we are going to see is nothing but that is of total station. Okay, so what is a total station? Okay, so we'll see. So the total station is nothing but a serving equipment, which is a combination of electromagnetic distance measuring instrument and electronic theodolite. Okay, so EDM we have seen, that is electromagnetic distance measuring instrument. Okay, and the theodolite which we use, it is a regular. Okay, and electronic theodolite is nothing but it is just the previous model of the total station in which we get the digital readings. Okay, so instead of noting down the readings which we see on the vernier A and B, then note it down. Okay, so likewise all the readings will be getting as an digital, okay, on the screen. Okay, so that is nothing but electronic theodolite. Okay, so total station is nothing but an serving equipment, which is nothing but the combination of EDM instrument and that of electronic theodolite. Okay, so it is also integrated with microprocessor, electronic data collector, and storage system. Okay, so whatever is the work we are going to do, that is of the serving work. Okay, so it is going to be stored in the memory, okay, of the total session. So it has having certain memory depending upon the said manufacturer or the memory which is been available. Okay, so in that whatever is the work, suppose it is to be done the measurement of area or calculation of the volume, okay, or road project survey is to be done or canal project is to be done. So hundreds of readings are supposed to be taken in such a case, so that are going to be stored, so that are being electronically collected. So when we just go on pressing the button, collect the data, that okay, if you are going to bisect the point, press the button, measure, it is going to note it down, it is going to store it. Okay, so that is nothing but integration with microprocessor, electronic data collector, and storage system. So the instrument can be used to measure horizontal and vertical angles as well as sloping distance of object to the instrument. So correspondingly, as we have seen the instruments starting from chain, tape, dumpy level, auto level, okay. Then correspondingly, we have gone through the theodolite, tachometer, substance bar, okay. or surveyor compass or prismatic compass. Okay, so each and every instrument has gone on getting modifying. Okay, and the last part, it is nothing but the total session. Okay, so it is combination of all that. So where we can do the measurement of horizontal distance, horizontal angle, vertical distance, vertical angle, as well as in the case of this total session, if you are unable to bisect perfectly horizontal, that is to the ground level, it is going to give the sloping distance also. Okay, so you can calculate the slope also. What is the slope of that? Okay, with respect to your station up to the point which you are requiring. So it also gives, along with the horizontal distance, it gives us the sloping distance. Okay, so this is what the total station which is mounted over a tripod stand. Okay, here you can see. Okay, so it is just been provided with a screen. Function keys are there. Okay, so correspondingly, telescope handle to correspondingly lift the instrument from the box and fit it over the tripod stand. So this is nothing but the prism which has been mounted over the said circular pole. Okay, so which is having a variable length. Okay, and a bubble tube is been provided here. Okay, so that the bubble remains at the center and you can perfectly bisect to the uh, center of the prism from the total station. Okay, so we'll see one by one. Okay, so this is nothing but the total station. So depending upon the made or manufacturing, the size or the correspondingly the design, they are varying. It might be button touch, it might be screen touch. Okay, and also whether it is a educational purpose use or it is a commercial purpose use. Okay, so we'll see first of all the total station. Okay, so here you can see first it has been provided with a handle. Okay, so the instrument just which we make use of the auto level, dumpy level, so they are light in weight. Okay, to carry. Okay, but this total station is somewhat heavy, so for that purpose the handle is been provided. Okay, at the top, so while fitting it over the tripod stand. Okay, so when you are going to fit it over the tripod stand, so one person is going to handle the he's going to handle the instrument. Okay, and another person is going to fit the wing nut to the leveling head. Okay, as you are supposed to take very precautions because the cost of this such instrument is in lakhs. Okay, so you are supposed to take the very precautions. Okay, you are supposed to take the precautions very carefully. Okay, so primary features you can see here. Okay, so heat is having a 300-meter range long link. Okay, so suppose you are going to connect it with the computer directly, you can make it use of it. Okay, so USB slot has been provided so that you can take the data and put it over the software which has been provided by the manufacturer and transfer the points. Okay, or the data which you have collected. Again, it has been provided with the battery. Okay, so depending upon the quality. Okay, so this instrument is having a corresponding battery life of about 36 hours. Okay, so it depends. Then correspondingly, here you can see high visible green and red LED guide lights are there. Okay, so just like our targets which are being provided, so we are knowing that before bisecting any object, we are making use of the targets. So for that purpose, guidelines are been provided. Okay, so function keys are been provided here. Here, electronic leveling system is been provided. Okay, so with respect to which you can do the leveling. Okay, so bubble tube is also there. Circular bubble is there here. Okay, so the basic case just like which we do in handling the auto level. Okay, so first of all, maximum bubble will be brought at the center with the help of the said tripod stand only, tripod legs only, and then only you are going to make use of this foot screws. Okay, also whatever is the work you are going to do, that is of the leveling. Okay, So it is been displayed over the tripod stand. Okay, so correspondingly that we are going to see during the practical session also. So that is been seen exactly here. Okay, that when you are going to keep the bubble tube or telescope parallel to the 2 foot screws, move the 2 foot screws inside outside. Okay, so according to that, the bubble which is been seen here digitally moves on the left and right hand side. Okay, so same deviations which you see on the dumpy level practical. Okay, that spirit level tube is there. Okay, or in the case of the such theodolite bubble tube, longitudinal bubble tube. So such bubble tube is been just seen here digitally. Okay, then correspondingly here LCD display and keyboard is being provided. Here laser plummet is there. Okay, so in order to mark the center or in order to do the centering operation, it is not required to release the plumb bob. Plumb bob also you can release, but along with that, a point laser is been there. Okay, so just by pressing the button laser option, okay, a point red point will be just marking towards the ground. Okay, so that you can check whether it is exactly centered or not. Okay, again the clamping screw that we are having to the theodolite regular clamping screw or tangent screw. So likewise only the clamping screw, horizontal clamping screw, horizontal tangent screw. Okay, so the outer side is having correspondingly tightening and another is here by which you can do the smooth movement, that is tangential screw. Okay, and it is having 500-meter non-prism range. Okay, so we'll move further. So we'll see one by one parts. Okay, so one, as I told you, this is nothing but the handle. Second one is the, here you can see handle securing screw. Okay, so it doesn't remove that handle. Then third, here you can see data input or output terminal remove handle to view. Okay, then fourth one is instrument height mark. Okay, here. Okay, so in the lecture I told you that if you are unable to take the backside reading of the say total backside reading when you are conducting, and if you are supposed to find out the HI, okay, so what you are going to do, you are just going to release the said your tape and measure the height. So there is a mark given. Okay, instrument height mark. Then battery cover is there, so which is being detachable. So whenever the work is there, just attach the battery, start the button on, press the button on there, and whenever your work is going to finish, just press the button off here and remove the battery. Okay, then here is the operation panel. Okay, so whatever are the function keys that you are going to do, it is there. Then here it is the tri-bar plate. Okay, then base plate is there. Okay, then foot screws are there. Okay, for leveling. Okay, then here is the screen display. Then objective lens regular, that is which we call as object glass. Then tubular compass slot is there. Okay, here you can see at the top. Okay, then correspondingly optical plummet focusing ring. Okay, so optical plummet is nothing but by which you can see the center on the ground. Then horizontal clamping screw, as I told you, horizontal clamping screw, horizontal fine motion screw. So along to that only the horizontal fine motion screw, that is nothing but the tangential. So during the conduction of the theodolite practical, you might have seen that when you are going to tie the upper clamp screw and you are going to make use of the tangent screw, upper tangent screw. So it is nothing for smooth movement, okay, for slow motion. So that is that correspondingly horizontal fine motion screw. Then here you can see the data input or output connector besides the operation panel. Okay, so whether it is a USB portable or a wire portable, so depending upon that, here from here you can transfer the data and take to the computer. Then external power source connector is there to some of the instruments. Okay, then plate level bubble, as I told you. Okay, for leveling, plate level adjusting screw. Okay, then correspondingly vertical cam screw. Here it is vertical tangent screw. Then telescope eyepiece. Here all the focusing screw and all the in order to clear out your eyepiece, all the screws are been provided here only. And peep sight. Okay, So that is nothing but the target by which, first of all, before bisecting any object, we have seen that we are supposed to make use of the peep sight. Here you can see, and 29 is the instrument center mark. Okay, so these are the various parts of the total station. Okay, so moving further, so we'll see what is the principle of the said total station. Okay, so what is the principle? Given the coordinate of the instrument position and bearing of a backward station, the coordinates of any other point can be computed. Okay, so what is the meaning of that? So coordinate system, so you are having x, y and z coordinates are there. Okay, so as we are dealing in the horizontal and vertical plane, so you will be dealing with three axes, that is nothing but correspondingly x, y and z. So what is the thing? So as we do that, if you are going to conduct the said leveling operation, what we do, we assume certain datum surface of the benchmark equal to 100. Okay, or we are assuming it is as in 500. Okay, so such kind of values, that is of x, y and z, so where the instrument you are going to keep it. Okay, so for that station point you are supposed to enter the coordinates. Okay, you can enter it 000, or you can keep it as 100. So with this, with respect to that, okay, that certain point, you are going to get all the data. Okay, so just I'll show it here. Okay, so this is suppose my position where I'm going to keep my total station, and if I am supposed to find out the horizontal distance or coordinates of all these points. Okay, so I will enter the coordinate of this point. Okay, and with respect to this, whatever is the horizontal distance, whatever is the height, okay, that is x, y and z, whatever are the coordinates, I am going to get it and get stored in the memory of the said total station. Okay, so that is nothing but dealing with the principle. So we'll see what are the important operations of the total station. Okay, so distance measurement, it might be horizontal or it might be vertical distance. Next, angle measurements. So similarly, it might be horizontal angle or vertical angle or bearing. Then data processing. Okay, so after measuring the distance, angle measurement, you are supposed to process the data. Okay, so which is going to be displayed over the screen. And electronic book, so that is nothing but our when you are going to make it use. Okay, when you are going to write it by hand, so that will be nothing but your field book, and whatever is data which is going to be stored in the said total station memory, that is nothing but your electronic book. Okay, so next is nothing but capability of total station. Okay, capability of total station. Okay, so the microprocessor unit in total station processes the data collected to compute. Okay, so correspondingly, whatever are the points that are being to be supposed to process, the data is being collected and data being stored. Okay, so average of multiple angles measured. Okay, we can do it. That is of the repetition method which we are done. Okay, then average of multiple distance measured. So what is the thing that when you are going to measure the first distance, you are going to check it whether it is going to remain constant or not. So depending upon the person who is going to handle that prism. Okay, so you are going to bisect that point only multiple times and you are going to get the average of that. Then horizontal distance, distance between any two points, elevation of objects, and all the three coordinates of the observed points. So this is the capability of a total station. So you can do the average of multiple angles measured, average of multiple distance measured. Okay, horizontal distance, then distance between any two points, elevation of objects, that is dealing with the vertical plane, and all the three coordinates. So suppose if you are going to deal with the calculation of volume, so you will be requiring all the three coordinates of the observed points. So you'll see basic components. So prism reflector. Okay, so basic component of total station is you are requiring the prism reflector. So it is a combination of a ranging rod, staff and optical cuboidal mirror. Okay, so as I told you, a prism is been just fitted over a small pole. Okay, so that is nothing but your ranging rod, so which is having 2 to 3 lifts. So lifts means what? You are handle the leveling stuff, so it is been openable. Okay, so it is been opened in parts. Okay, it is been opened in parts, so that is in 2 parts or 3 parts, so that is lifts. So with 5 centimeters interval, so graduations are given, so just like our which we are having graduations over the said leveling stuff, so likewise they are been engraved. Okay, so as it is made up of steel. Okay, so correspondingly that whatever are the graduations that have been just engraved there, so which are having a interval of 5 centimeters. So according to that, you can just fix up the height of the pole, and you are supposed to enter in the total station. So by which you can know the height of the total station, that is the HI. Okay, so the height of this prism reflector is adjustable from 1.5 meter to 3.75 meter. So generally, we deal with 1.5 meter only, because at a 5 feet we can correspondingly handle the prism. Okay, so you can see it, and more number of prisms will give more accuracy. Okay, so what is the meaning of that correspondingly? So what is the thing with a total session? A single prism is coming. Okay, so when we purchase a total session, so according to that, with that a single prism is there. Okay, and in order to do the work in faster mode, if you are having more number of prisms, okay, you will get the more accurate results. Okay, so now how you are going to maintain the accuracy of total session? Okay, so more accuracy can be achieved by careful centering. Okay, so as I told you, more precautions are to be taken. So it is not just like our handling the regular auto level, dumpy level, or theodolite. So in order to get the accuracy, you are supposed to do the careful centering, then accurate pointing the target. So correspondingly, whatever is the center of the prism, you are supposed to point it accurately. Then take the average of multiple points, then better optical lens. Okay, so you are supposed to make use of the optical lens which is good, okay, or better, so which with respect to which you can get a clear focus. Okay, strong tripod. So the tripod which we use for the theodolite, so it is not sufficient or it is not strong enough. So for that purpose, a specially designed tripod stand, okay, which is strong enough to sustain the load of the said total session, it has been provided along with the total session when you are going to purchase. So as I told you in the starting only, it is somewhat heavier as compared to your regular theodolite or all other instruments. So verticality of prism pole. So this verticality of prism pole will depend upon the person who is going to handle the prism. So the angular accuracy is from 1 to 20 seconds. Linear accuracy is from 2 mm to 10 millimeter per kilometer. Okay. Also, this can be reduced up to 1 millimeter. Okay. So by making the practice of handling the instruments, you can get the accuracy, whether it might be with respect to angular or it might be with respect to linear. So different instruments, as I told you, so different instruments are having different accuracy. So depending upon the made, that is the manufacturer. So here you can see, so there are 3 manufacturers. So first one Nikon, second one is Leica, third one is Sokia. Okay. So all of these are having an accuracy with respect to in measurement of angle. It is 1 second. Okay. So and basically the thing is that the totalization comes with or without prism. Okay, some of the totalizations are like that they don't require any kind of prism. Okay, so directly they can give the result by bisecting any of the object. If you are wanting the horizontal distance, so in that case you can make use of that instrument. Okay, so better to use the prism in order to maintain the accuracy. Okay, So linear accuracy for the Nikon company, it is plus or minus 2 mm when you are going to make use of one prism. So when you are going to make use of three prisms, okay, in a range, so you can reduce the accuracy up to plus or minus 1 mm. So more greater accuracy you will be getting. So similarly, it is with respect to Leica and that of Sokia. Okay. So this accuracy varies with price also. Okay. So as I told you, whether it is a single prism, so up to 2.5 kilometer you can get the correct result. When it is been having two prisms, it is going to be up to 5 to 7 kilometers, and when you are going to make use of the three prisms, it will be more than that. Okay. So in this way, you can maintain the accuracy of the total session. So what are the functions of total session? So it simultaneously measures angles and distances and record. Okay. Then correspondingly, correcting the measured distance with prism constant, atmospheric pressure, temperature, curvature of Earth, refraction correction. Okay. So you can measure the correspondingly all this. Okay. Compute the point of elevation, that is RL. Then computing the coordinates of every point. So as I shown you before that, in order to measure the area, you are requiring the said the x, y, and z coordinates. So with respect to that, you are going to calculate the other coordinates of other points. Okay. Then remote elevation measurement, then remote distance measurement, area calculations, data transferring facility from instrument to software and software to instrument. Okay. So you can transfer either the data from your instrument, which is been collected from the field work, to the computer, that is via software, or from software, that's from computer via software to the instrument back. Suppose any data which you have done previously and that you are taken, that is we are having a practice of control X, that is cut paste. Okay, so somewhat suppose the data has been directly transferred to the computer, and in the future if you are supposed to do the same work, okay, so what you can do, just transfer the file, okay, into the instrument, and you can continue the further work. Okay. And format of conversion of units, so how you are requiring the said unit, in what terms you are requiring. So in that unit you can have the said conversion of units. Okay. Then we'll see what are the applications of total sessions. So updating mapping, topographic survey, hydrographic survey, cadastral survey, project construction survey, road rail survey, mining survey. Okay. So these are the various applications of the total sessions. Okay. So you are knowing updating mapping, corresponding topographic survey, hydrographic survey, dealing with the water, cadastral survey. So if you are dealing with a particular plot, with that road railway survey in order to mark the center alignment, then mining survey in order to calculate how much the work has been done. Okay, so that will be the correspondingly used in that part. So what are the operations that are involved? We'll see using the total session. Okay. So establishing the site datum. Okay. So selecting the site datum, establishing the north. Okay. Then setting up the total session, placing and labeling tripod on datum, placing and labeling the gun on tripod, linking the data connector to gun. Okay. Data collector options and settings. So which is main menu basic settings. Okay. So these are nothing but the basic requirements which you are supposed to do when you are going to handle the SID total session instrument. Okay, then create and operate the job files. Okay, so what is the thing that whatever is the work you are going to do? Suppose I am interested in measuring the area. So for that purpose, I will be requiring to store all level or whatever are the points that I'm going to collect, whether it is a horizontal distance, horizontal angle, or said vertical angle, vertical distance. Okay. and the coordinates x, y, and z. So that should be stored in a single folder. So for that purpose, you are supposed to create the job file. So just like we what we do while handling the computer, we make a folder, and in that sub files are there. Okay. So whatever is the work, we are going to just store it there. So likewise, we are going to create an operating job file. So create a new job file, or you can make use of the open of the existing file and go on adding in that only. Okay. Then correspondingly shooting points. So that is nothing but bisecting the points and taking the readings. Okay. So identify the important points to shoot. That is taking the reading. Then we are going to take the points. Then additional points if they are required, and noting the special features. So just like detailing it. Okay. So that we are going to do it when you are going to create or make use of the existing file. Then post processing data. Okay. So now after taking the readings, okay, whatever are the readings, okay, that are been taken from the field, that we are going to transfer it over the software, or basically we make use of the software that is AutoCAD. So where you can as it is hands on, okay, user friendly. So directly data we get there. Okay, so in that that is nothing but post processing. So data will be downloaded, conversion will be made. Okay, and correspondingly, as you are knowing what is the ground nature, so likewise that which points are there. Okay, so according to that only the naming is been done. Whenever you are going to shoot the points or correspondingly note down the points, so it should be in neat manner. Okay, so first point which was where it was located, second point, third point, fourth point, fifth point, because whatever is the plotting or map generation you are going to do, so in that case you will be requiring the basic data, how it was been looking. So whether it was a square one, whether it was rectangular, whether it was a circle one. Okay, so likewise you will be requiring. Okay, and then you will be preparing the map. Okay, so moving to the next part, computer software packages. So the following post-processing computer software packages are in use for various engine applications. So ArcPad, ArcView, ArcInfo, that is conversion from raster to vector form. Then MicroStation, map generation. Then ADAS, image processing software. Surfer, auto plotter, civil CAD, Pythagoras, preparation of controls. So you can prepare the controls also, and survey to draw the cross sections and longitudinal sections. Okay, so the information received is to be analyzed depending on the user's requirement. So as I told you, so whether you are requiring only cross section, or if you are requiring the total area along with the detailing, and as per that only you are requiring, suppose the said contour map also, how is the actual ground, okay, where there is a slope, presence of a hill or valley. So correspondingly, you can prepare by making of these various softwares. Okay, and it is not a rugged instrument, so it is a sensitive. Okay, so prism verticality is the questionable, because the person who is going to, as I'm telling that, it depends upon the person who is going to handle the prism. Okay, so visibility is must, so correspondingly the prism should be visible. It is more expensive, it requires calibration at every 6 months. Okay, so it is not a case like that ki after 1 year you can do on taking out the rings. So as I told you, whatever the reading, so you are requiring the accuracy, and for that purpose only you are going to make use of the said instrument total station. So it requires calibration. Okay, so amount of error is greater at shorter distances. Okay, and height of instrument and prism is to be fed. Then awareness on battery maintenance, because suppose the battery remains on, so after a certain duration, the battery also get damages, and the cost of such batteries in is in thousands of rupees. Okay, so it varies from 15,000 to 25,000 only battery. Okay, so for that, it is to be to establish north compass is required additional. Okay, so after that only you can make the bearing. So finally, we'll see what are the safety precautions. Okay. So focusing directly at the sun can result loss of eyesight on the spot. Use a filter when observing the sun. Okay. So filters you might have seen for the prismatic compass, which are there. So if there is any problem regarding bisecting the object, so in that case you are supposed to make use of the filters. Otherwise whatever is the focusing that is of the object glass, it will get damaged. So never remove the hand grip carelessly. So that is, if the grip is loosely or incomplete attached, the instrument could fall and may cause a serious injury. So as I told you, it is a heavy one. Okay, and and I told you that one person is going to handle the instrument, and second one is going to fit it from the bottom. That is, wing nut is going to be attached, and you are going to check it whether it has been fixedly tightened or not. Suppose it is not, then if it has been loosely joint or connected to the wing nut, so it may fall on your leg and you will get seriously injured, and there will be damage to the instrument also. So make sure not to short the battery terminals. If these are shorted, the resulting high current would not only damage to the battery but also start a fire. Okay, so what is correspondingly, if you are going to make use of the external source instead of making of the regular batteries which are been provided with the instrument when we purchase, so if there is somewhat, if you are going to plug plus to minus and minus to plus, okay, and there is suppose fluctuation of the voltage, in that case the battery will get damaged, okay, or the battery terminal, and also it might catch fire. If the instrument or battery comes in contact with water, wipe it off as quickly as possible and set it in a dry place for a while. So when it is completely dry, then put it back in the case. So case is nothing but the box in which the total station is present. So you might have listened that whatever is the work has been going on, the surveyor is doing in the rainy season also. He is not having any kind of problem. He's just covering the instrument. So if they are telling, if the battery gets it comes in contact with the water, so it suddenly it should be wipe it off, it should be cleared out and placed in the dry place for a while, so that you can make it use in the future. Okay, never disassemble the instrument. If you find a problem, you are supposed to contact the dealer. So what is the thing that we are knowing, that if there is any damage in the instrument, what we do, just okay, so there is one star screw is there, or it is a plus or minus screw is there, so you can make use of the regular screwdriver or make use of the star correspondingly screwdriver and open it, and we'll see what is the damage to that, and we'll work it out, okay, by seeing the videos over the YouTube or something like that only, or by making use of the our own knowledge. Okay, so it is, as the instrument is costlier, you should not do such kind of things. Okay, never disassemble the instrument, directly contact to the dealer. The dealer will send his person, he will see what is the problem. If it is a smaller one, he will do it on his own on the same place, or if it is a bigger one, he will just take the instrument with him, okay, with due permission of you, okay, and whatever is the problem facing with the instrument, that he will tell you. Okay, so that was regarding the SID, our total state total session instrument. So in which we have seen the SID, what is total session components, what is the principle, okay, then what are its basic parts of the total session, how you are going to handle it, okay, so which manufacturer is having which quantity, okay, what are the basic functions and what safety precautions you are supposed to carry out. Okay.